Hey everybody, happy Thursday. Sorry again to be late with this. I definitely totally misestimated or whatever I had in mind, thinking I'd have so much free time sitting at a hospital all day long, but that has not been the case, so I apologize. This week is a little crazy. Next week we should be back on track, so thanks for your flexibility. So we've got to finish up with chapter 5 here. I left myself a note. I'm going to start with some nested loops here on Thursday, and then we'll finish up the rest of the content. So we got nested loops, this developing incrementally, we've been doing this entire time. Break and continue in loops. It's generally considered bad form if we can avoid it. We try to avoid it if we can. They do have some really good uses, but they're just kind of confusing. The loop else is kind of fun, and then this enumerate is really cool, and then I think I'd mentioned we're going to try this dice statistics. We're going to expand on it for our lab on Monday. So I'll let you guys know. I'm not sure if we're going to be back in town on Monday or not. Depends how long it takes to drive home from Philly. I'll let you know plenty of time in advance if I'm not going to be able to make it. We'll know Sunday for sure. So just keep an eye out for that. And then don't forget, you do have to do these iLabs. You get the points for completing these iLab exercises, and I know they are ridiculously specific, like down to the space, but it's good practice for making sure you have everything you need exactly as it was said in the description. And then that'll finish up our loops chapter here. I think, yeah, Project Zero, it's going to be due October 8th, so hopefully you've got a chance to get through this one already. And we've got another week if you need it or so, but it's due by 3:30 p.m. Thursday, because I'll be going over the solution Thursday in class. So make sure you've got started on this. Please don't leave it for Thursday, and ask me lots of questions on Thursday. That never seems to work out well when lots of people have questions on the same day. So start early on it. I think we talked about this one already, right? We're building that little lotto simulator. So we're keeping track of their total spent, total won, and their net loss. And it's just $1 per ticket, and we're just doing the simple little fake numbers here, or fake wins here. So if they match all the numbers in order, it's a $5,000 prize. And then we're going to check for the one-off win. If they match 3 numbers in order, and the fourth is 1 off, so it's 1 higher or 1 lower than the other number, the actual number, then they'll win a $275 prize. And we're going to print each time the total spent, total won, net loss, and they just keep going over and over and over until they want to stop, either with an easy pick ticket or if they want to pick the numbers themselves. Okay, so we're using loops for that one. We're going to keep them inside of that until they tell us they want to quit. And then we use that little random number generator, so you can see how to pick your own numbers here. We should be in pretty good shape. We're moving right along. All right, so thank you, computer, for reminding me to start with our nested loops. And you know what, I'm actually going to do, because I don't want to have to rerun through this every time I run stuff, so I'm going to make a new project, though. So, sure, so this is Chapter 5, Loops Part 2. That way we don't have to see all that stuff before, so hopefully make life a little easier. All right, zoom that in here, and we should be good to go. So we looked at the different loops, right? We have the for loop that will take each item in a collection, and we have the while loop. So depending on what we want to do, if we have a collection where we're probably going to use a for loop, if we're just going to do something a set number of times, or you can use a for over a range, right? If we know it's going to be 10 times, you can say for number in range 10 or something like that, and you don't even have to use the number as well. So if we wanted to, just for fun, imagine we were going to do, just print out all the possible times in military time, 24-hour time. So we're going to say hour starts off at 0, and minute starts off at 0, and seconds starts off at 0. Okay? And we're going to do this while hour is less than 24. As long as we're less than 24, we are going to keep going in our clock. And what we want to do is, well, we're going to loop again. We're going to say as long as my minute is less than 60, I'm going to keep doing something. So every time an hour happens, this loop will run from beginning to end. So it's nested. And then we're going to do this crazy third here. Well, seconds is less than 60. We're going to do something else. But here we're going to print, and let's see. I think we can get this nicely formatted string. We'll do hour as a digit. Oh boy, we got to look this up again. Python format integer. Here we go. Let's see. Yeah, colon Integer formatting. That might be it. There's a Stack Overflow hit. So yeah, colon. Let's do D. So we want 0 to D is a digit, and we want 2 places here. So even if it's a 0, we want 0, 0. I think that's what that does for us here. Let's try it, and we'll do the same thing here for minutes and for seconds. We'll see what we get. Minutes. Oops. Oh my goodness, too many. Bad copy paste. We'll do minutes. That should probably be hour, minute, second. Minutes, hours. I like plural. I'll make them all plural here. Minutes and seconds. We'll print that, and then when this thing runs, right, our while loop will be an infinite loop if this never changes. So we're going to take seconds plus equals 1. And this will run then 60 times, and then it's going to stop. And it's going to come back up here, and this loop will come back to right where we were. So this loop will run at 60 times, and we want to, when that loop is done, right, once this loop is finished, that 60 times I'm going to take my minutes plus equals 1. Right, and when that loop is done, I want to take my hours plus equals 1. Right? So this loop here will run the 60 times, print it all out, and then we'll add 1 to minutes. And then we're going to come back here to the top and try this again, 60 more times, and 60 more times, and 60 more times. So let's see if that works for us. Come on, where's run? We get, oh, we missed a colon. But we get the padding, so it looks good so far. Oh, but it stopped at 0, 0, 0. Oh. Well, 60 seconds is less than 60. We never put seconds back to 0. Right? So at the beginning of every minutes loop, we want seconds to start back at 0. And we're going to have to do the same thing with minutes here. So at the beginning of every hour, put minutes back to 0. So this is going to reset it so that I'll get 60 more runs here. And this will reset it so I get 60 more runs here for every hour. Let's give that a shot. Look at that. All the possible times from 0, 0, 0, 0, 0, 0 to 23, 59, 59. With 3 nested loops. And you can nest as many loops as you want. You could go nuts. I don't recommend you go that far. This is probably far enough, but you know, maybe you'll find something interesting to do with 3 nested loops here. So again, the idea here is for every run of hour loop, the inner loop runs from start to finish. Right? Something like that. And I guess if we wanted to be even fancier, we could do a range here. Well, let's try it again. Let's see if we can double this loop in using range notation here. So we're going to say for hour in range 24, which will give me 0 to 23. And then we want for minute in range 60, should be 0 to 59, and for second, or seconds, right? Seconds, hours, minutes, sure. In range, maybe it should have been plural. I don't know. Not sold one way or the other. For seconds in range 60, let's print this out. And see if that works. So let's see if we get a second time. And there's once, here's the second time. Awesome, so this is nice because the range is going to restart automatically. So for every run of hours, it's going to just rerun this range. We're going to get a new set of from 0 to 59. So both work, you know, depending if you like for loops instead of while loops. And totally up to you, just a preference. I don't think there's really one way or the other that's better. This was kind of nice because we didn't have to worry about resetting it. We didn't have to worry about incrementing it. So this was a little bit more concise. And maybe that's a win, right? Saving a couple lines of code. But you can do all sorts of fun things with nested loops, right? So you'll do something in the outer loop, and for every time of that outer loop, you'll run the inner loop beginning to end. The book has a couple of, or Zybooks has a couple examples you guys can go through for fun. We don't need to do all those right now. So those are nested loops. Looking at break and continue. Now again, I'm not a fan of these just because they're confusing. So we can do some sort of loop. We're going to say, we're going to do a silly thing, say while true, and we'll get some input. I don't know, the answer equals an int of an input. We'll just do a regular input. What is the answer to life, the universe, and everything. Maybe I'm butchering that quote here, but that's okay. Right, so we prompt them, and then we can say if answer is equal to 42, break. And break is a keyword here that says stop the loop. Make the loop stop. We're all done with the loop. So you can see why it's kind of silly. If we know it will stop the loop, we probably just want to put it in the while condition. Now there are cases you might want your loop to stop midstream, like in the middle of doing something and not continue on to the bottom, but I tend to find these just awkward to follow and more confusing than they're worth here. But we should be able to get prompted here, and we'll just keep getting asked over and over and over. As long as it's not 42, we're just going to keep getting prompted. Type in whatever I want, right, yada yada yada. If I do 42, the loop stops. So, you know, this is a bad loop, right? So break, it's handy. It can be useful for things, but typically we frown upon it. I frown upon it. The other option you have with a loop, a special keyword here, is a continue keyword, and that one is also kind of confusing. So we're going to do a loop here. So we'll say for number in range, I don't know, let's do 100. And what we want to do here is we want to say if the number modulus 2 is 1, so it must be an odd number, print odd number. And then, oh, here, let's do this. Let's just this silly interview question. I don't know why they used to give it. It used to be kind of popular, but it got really silly, and it's a terrible question. Like anybody should be able to do this after your exact first programming class. It's not hard at all. You say fizzbuzz. So if a number is divisible by 3, you want to put fizz. If it's divisible by 5, you want to put buzz. If it's divisible by 15, you want fizzbuzz. So that's a programming interview question. Yeah, it's trivial, so it's totally silly here. So we're just going to loop. So let's do that. So let's say if the number is divisible by 3, so we get no remainder, then we'll print fizz. And then else if the number is divisible by 5, so if we get no remainder, we want to print buzz. Else print number. And what we're going to run into trouble here, and this is maybe why it's an interesting question, is a number divisible by 15 is divisible by 3. We'd only get fizz. Okay, but we want fizz buzz. So a couple different approaches here. We can just say if here, and a couple of you guys saw you could change this ending character, n equals to nothing, that sort of thing. So it's printing all in one line. Equals nothing. Then, but if one of those, yeah, then we get the same one together. This is not great here, but that's okay. So we get fizz, and then we might get buzz. We get fizz buzz if it's 15, but then we need to figure out how we get a number if it's not one of those two things here. Let's see. So we can say if it's not divisible, I don't know. All right. I'm not a fan of that. Let's change that. Let's put that back. We'll just say if here. Whoops. We'll say if number mod 15 is 0. We'll check that one first. We'll print fizzbuzz. Else if, else if, else if. Right? Sure. We could do it this way if we wanted. If you don't like chaining these all together, now let's just make sure it works actually, right? Let's run it out. Always good to write your code modularly, just like the textbook said, right? So we'll check the first couple. 1, 2, fizz, 5, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz. Yeah, I think that's fine. Maybe 2 Z's there in fizz, buzz. Sure. Oh yeah, it even knows this is misspelled. And it knows fizzbuzz is a legal word, apparently. That's pretty fancy, PyCharm. Anyway, so yeah, at 30 we should get fizzbuzz. Yeah, cool. So if you don't like this particular formatting, no, that's okay. You don't have to. We've got options. Let's do it a different way here. And we're going to take advantage of that other keyword called continue. So continue says go back to the top of the loop. Well, that's it. continue. So if they wanted to get fancy and say, hey, how could you write this without any else's here, with only ifs, right? If it's 15, divisible by 15 will continue. That means skip everything else and go back to the top of the loop. If it's divisible by 3, skip everything else, go back to the top of the loop. If it's divisible by 5, skip everything back to the top of the loop. If we didn't do one of these ifs here, right, we're going to print the number. So it's not an else, but we know it's essentially an else because we're continuing out of the loop. It's just a silly little, can we write it without an else statement? And just, if someone knows this, you can use these continues, sure, they'll be able to do it. So it should have printed twice, right? Yep, okay, there's the repeat, so we're going to check the second time, see if it looks good. 1, 2, fizz, 5, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz. Looks pretty good so far. I think that sounds about right. So again, continues are just a little bit awkward. So if there's a way to not use them, that's typically the better way to go, because it breaks the flow of code. But you know, there's nothing wrong with using them. It's just it's a little harder to read. So if you like them, great. If not, I'll never ask you to use them. Okay. Let's break and continue with the loop else. That's kind of fun. So because there's this way of breaking a loop here that will end the loop, what do we say, not normally. Like, so normally a loop ends when this becomes false. We can run a loop and we'll say while let's see. Oh, here we'll do a number guessing game here. So we'll say random number, or magic number again, right? Magic number can't type. Magic number equals, and we got to go import random if we're using magic numbers. Remember that from last time. Import random. Random.randint, and we get a range here. I don't know, say 1 to 100, and this is inclusive, which drives me nuts. I can never. I don't know. I guess I'm getting better at remembering it here. But it gives you a random value inclusive of A to B. I think, is there a way to see it? Oh, that's fine. All right, and then we're going to say a guess here equals, I don't know, 0 because it's invalid, while guess does not equal the magic number. Let's keep guessing them. So we'll say an int, the guess is equal to an int of an input, turn a number between 1 and 100, or -1 to give up. And what we can do here is, right, all we need to check inside the loop, because this will tell us if we're right or wrong here. This is just a straight guessing game. We're not going to give them too, I guess we could give them too high, too low. What we can say, so if guess is equal to -1, break. Okay, so that will end the loop, like hard stop, end the loop, game over, we gave up, right? Otherwise, we can do these other operations, right? If the guess is less than magic number, we'll print too low, if guess is greater than the magic number, print too high. Sure. And I guess that's not even, doesn't even need to be an else. Right? If you want to do this without an else, that sort of thing, it's just a contrived example. But if we break out of a loop, it forces it stopped. But what you can do is you can have an else in your loop, which essentially is the else to this if. So a while expression is similar to an if, right? You have a Boolean expression here. If this is true, the loop runs. What the loop else does is when it becomes false, this runs. So as soon as it becomes false, the loop stops, and then the else will run. So we can say, you got it right. Yay. Because if we break, this never became false, so my loop else doesn't run. So instead of having a yes, you got it correct inside the loop, we can attach it as an else because we know we're breaking out. It's just a silly example showing how you can use a break that does not trigger the else. So let's give it a shot. Oops. Oh my goodness. There we go, 42. All right, enter a number. Let's do 50. It's too low, -1, I give up. And we got no message because I broke out of the loop. And just one more time, let's go guess that number. We had a lot of fun guessing numbers last time, didn't we? Let's see, so 42. All right, so 50 is too high, 25, too low, 37, too low, 40. 44, I forget where the middle is. 40 is too high, 30, 38. We got it right. See? This loop became false, so we get the else. We got it right. So that's it for that one. That's the loop else. Enumerate is pretty handy here. So if we were doing looping over a list here, we had a, what do we have? I don't know, names here. We had Eric, John, and Bob, and Mary in our list here. And we could say, for index in range, length of names. Because if you want to be able to modify these, remember you need to go get them by the index value. We can't do a for loop that says for name and names. Remember, you can't modify items in the loop with that sort of loop, but if we need to get them by index, we can. So I can say names at index, I don't know, plus equals, I don't even want to add anything. No, I don't even want to do that. Let's just print them. Right? We could say print, let's do a formatted string. We'll say at index is names at index. So we'll just say, hey, this is your index position, right? So we should get 0 is Eric, 1 is John, 2 is Bob, 3 is Mary, because we always are 0 based. So we get 0 for the first, 1 for the second, right? On and on and on. So let's give that a shot. Excuse me. All right, 42, -1 to give up. There you go. So index 0 is Eric, index 1 is John, index 2 is Bob, index 3 is Mary. Well, it turns out this is somewhat common, and we don't, we're a little bit lazy sometimes, and we don't always want to have to say this, my array, my list at index here. So we've got this cool option. We can say for index and value in enumerate names. I don't know if this is any faster, but we'll do the same printing thing here. We'll just say this is now value here. So I can get the item out here, we'll just call it value. So you hand enumerate in the parentheses the collection you want to enumerate over. And it gives you 2 items. So this for loop looks really funny. We're saying for this, comma this, so we actually get 2 values out when we're enumerating. We get the index and the value each time. So we can print it out. So if you want that index number for some particular reason, you can use the enumerate and you'll get them both without having to do an index for range and length. And I just like the for range and length, but that's just me. It's just a personal preference. All right, and the last thing here was dice statistics. That was kind of fun. So we said, hey, like die1 is equal to random.randint from 1 to 6, and die2 was random.randint from 1 to 6. Right, and we wanted to do this a bunch of times. So we were going to say for roll in range, I don't know, let's roll these. I don't know, what should we do? How about 36 times? Right, we're going to randomly assign values to die 1 and 2, and then we'll have a sum is equal to die 1 plus die 2. Right, and then we need a way to store, or we were counting how many times, like we got a 7, right, out of those 36 rolls. Let's look for that. So say if sum is equal to 7, this is important if you play like craps or some sort of silly casino game where they're going to take your money. All right, so if sum is 7, it's not good to call something sum because there's a sum function you can give on lists. I don't know, so we'll say sum of dice. Sure. Sum of dice, if sum of dice is 7, so we need a place to count this. So this is a number of 7s rolled, and we start off at 0. If it's a 7, we get that plus equals 1. Sorry, let me space that out. I'm unhappy with my spacing. Right, and then we're done with that loop. We can say print f formatted string after 36 rolls. Or I don't know, in 36 rolls, simulated rolls, 7 was rolled, number of 7s rolled times. Right, so we'd expect that to be the most common, right? If you know anything about rolling dice together, right? Because there's the most possible ways. So I think we should get, what, 6 of them or so? And it's not perfect because it's random, mostly random numbers at least. 42, we'll give up. There we go. Hey, 3, oh, we only got it 3 times. Wow, let's try it again. Yeah, that's fine. We'll try it again, see what we get. There we go, 4 times. So sure, I mean, it's only 36. So the more we do it, the closer we should get to the 1/6 chance. Let's double check that. It's the probability. I spelled it wrong. Probability of rolling 7. Yeah, there we go. 6 out of 36 chances here. Look, it even knows I meant out of 2 6-sided dice. How smart is that? How cool is that? So the more we do it, the closer we should approach that 1/6 number, because we're just simulating here. So we're not guaranteed to get it. This would be 4. That was 3. You know, I'm a little bit sad we didn't get more of them, but that's okay. So that's that dice practice is similar to this. You're going to tweak it a little bit, and then we'll have some more fun with it on Monday for lab, getting a chance to do more and more nested loops and playing with loops and different kinds of loops, while loops or for loops, whatever you're comfortable with. Right? Any for loop could really be a while loop. Right? You can loop over items in a collection, but you can't always replace a while loop with a for loop. Right? Like when we think of those like sentinel value loops, we're going to do something until we get a particular value. We can't use a for loop for that. So, but for loops are just handy little shortcuts, I think. A little bit less code. All right, so I've got all that. I think that's all we've got here for that chapter. And when we get back next week, we'll pick it up with chapter 6, looking at functions, and we're just moving right along. You guys are doing great. So I'm a little behind on doing the grading stuff. Again, totally miscalculated how much free time I would have, so I apologize for that. But do let me know if you have any questions. I do prefer you asking questions in the Discord, because everyone gets to see the question and the answer, just like if we were meeting in class, and you could, or live streaming in class, I guess, for this COVID era. You could stop, interrupt, ask questions, and everyone gets to hear the answer. Because if you have a question about something, I can pretty much guarantee someone else does too. So please hit me up with questions on Discord. If you want, you can still email, call, text, whatever you want for questions too as well. So, I got one joke. I don't think I told this one to you guys yet, but I just found out. Do you know how bicycles are really common? Bike is not actually short for bicycle. Bike is short for bicycle. All right, that was a bit of a stretch, but you guys take care. I'll see you around.